Yesterday, we did that last little bit of hyperbolas. I showed you guys the trick on 37, 39 about the whole fraction thing. Now, I think I started 37, so I'll show you how to start 39. Is that what you're looking about? So on 39, back to the trick about how to get rid of the value within the numerator. That means we want to multiply that top and bottom by the same factor of 1. So we're going to divide it by 1 9 or times 1 9 over 1 9. So if I multiply it by this complex fraction of a ninth, when you distribute that through, 1/9 divided by 1/9 is how much? It's just 1. Okay. So 1 times the x squared over 64 is still x squared over 64. 1/9 times the other one winds up looking like this. You get 1/9 over 1/9 times 9 over 1 y squared over 4 over 1. So if you distribute that through, that's what happens. Why doesn't it? Because what's 1/9 over 1/9? 1. I don't have to worry about that here because now that eliminates that fraction, and it just creates it down here. That's the trick. And obviously, you won't do anything to the 1 then. So your final equation would be x squared over 64 minus y squared over the crummy fraction of 4/9 is 1. Okay. X squared came first, which means what direction does it go?
Side to side.
Side to side goes left, right. Very good. So oh, hit the wrong button. Yeah, Devin. Hi, Devin. There. Hi, Devin. So we can barely hear him, so he's there. So what happens with this, if you go to start graphing, we know our center is at the origin. We know that our a squared value is 64. Our b squared value is 4/9. The c squared value is just going to be those two added together. You just get some crummy values and go on from there. A plus or minus 8, b plus or minus 2/3. So if we start thinking that it's going to go left and right, I just want to show you this about the slopes. Two-thirds is a little bit less than 1. So you're sorry, those look more like a curve than a whoa. If you squint, it looks just fine. So what's weird here with the slopes, guys, the slopes here, your slope is your rise over 1. We went up 2/3, we went over 8. So it's 2/3 over 8. So if you put, that's a complex fraction. Your calculator does that. You can do an alpha y equals of an alpha y equals and make a complex fraction. Did you notice that? Little trick. So if you do that, so it's 2/3. Number in. It'll do that. There's your slope. Huh? Oh, I I did, yeah. There you go. It should be like that then. There you go. Sorry about that. I didn't realize that's what it did on the bar there. Okay. And go from there. So after that, it's just you get some crummy numbers. Okay. Tomorrow, what I'm going to do is a song. I know you want me to start dancing. Arrow down. Tomorrow what we're going to do is I will collect the homework from 2, 3, 4, and 5. I'll collect those 4. What's that? Oh, we have homework tonight. I'm collecting this, and then today we are starting on shifts. Okay. If you do an alpha y equals, then do another alpha y equals, it should make the fraction at the top over 8. Devin, I'll worry about getting your stuff. We'll get it all scanned up, not to worry, okay, bud? All right. So let's do this. Today we're going to talk about shifting. Today we're going to talk about shifting all the conic stuff. And so when we start talking about shifting, what's going to change here is really the only thing that changes is, excuse me, your center is no longer at the origin. Your center is going to be located at some value of h and k. What's that? Yeah, well, it's just think of it as shifting. The textbook calls it this. Just think of this as a shifting. Usually shifting takes us a good solid 2-3 days without a big deal, sometimes 4, just to make sure we get everything down. Because you're going to find out real quick, it just takes a little bit longer to do certain parts. Today we're just going to focus on graphing and labeling. And my goal today is just kind of do one of each style problem. Tomorrow we'll talk about what happens when you have it in what's called a conic form. How do you write it into the form to graph and go on from there. And then Friday, then we'll talk about is writing the equations given a center, a focus, and things like that. But it all stems from the idea that we remember always that A is the distance from your center to the vertex. B is always the distance from the center to the covertex. And C is always the distance from the center to the focus. Those 3 things will never change regardless of the equation of the conic section. A, B, and C is also always stay the same. Now, I know that you guys, we've already looked at the 4 different formats of them. If you go back to your calculator, you will see what all 4 of them look like. And I apologize, I had completely forgotten that normally at this point I make a photocopy of all 4 formulas, just give you guys a little hash sheet so you have it with you, so you keep looking it up on the calculator. So I will have that for you tomorrow. I did not get a chance to get to it today, so I'm sorry that you have to press a button. So basically what I do for you guys is this, is that I will print out these 4 equations for you. That way you can see what they are all at once without having too much to worry of it. Those 4 are all just right on the calculator. I've said this before, I will always allow you to have the formulas. Whether it is with your calculator or a dummy calculator, I will always provide those formulas for you, okay? Happy birthday, let's sing. Ready? 1, 2, 3. Happy birthday. It better be his birthday. Happy birthday! Happy birthday! Bender said it was. I just thought going slower today. We're at an easier. We're at a point now where we need to slow down just a smidge because this stuff is kind of crazy. All right. So don't worry about writing all these out. They're on your calculator. I'll give you a handwritten out one here tomorrow. It won't be a problem. So what I want to do is jump right into it. I want to jump right into Graphing and labeling. So I'm going to graph quantity x minus 3 squared plus y plus 2 quantity squared is 16. So when we do these things, what we want to try and do is we always want to try to figure out what conic section is it to begin with. It's going to be a circle, and the reason that it winds up being a circle is because if you were to divide everything out by 16, your A and your B values, your A squared, B squared, are the same. When that occurs, that means you have a circle. So you only had two possibilities with this. It was either going to be a circle or an ellipse. And the reason that is because we've got the plus sign between it. So we know we have a circle, and the circle equation looks like this. X minus h quantity squared plus y minus k quantity squared equals r squared. Which means, where's your center? Yeah, our center is going to be located at hk. In this case is at 3, negative 2. And what's your radius then? 4. Okay. The radius is 4. Okay. So circles, I figured we'd start with something easy because usually circles make you smile in a roundabout way. We have x squared, y squared, plus sign between, means it can be either an ellipse or a circle. When I set the side equal to 0 by dividing out by the 16, I have the same a squared and b squared value. And if a squared and b squared are equal, it means it's a circle. Okay? So we start by plotting. There's my center, 3, negative 2. Now the really tough part. I know. Labeling the other parts of the circle. Okay. Good luck. Ready? What's the radius? So let's go. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 4. I try very hard. And then the really difficult spot. That was pretty close. It's not bad. And there's your circle. Circles are very, very easy to graph. Okay? Circles are very easy to graph. We'll get into the idea eventually where we'll talk about write the equation, line the tangent through the radius, all that. We'll get to that, but for now, we're just shifting the graph. Graph. Okay. And let's try number. I have the equation y plus 2 quantity squared minus the fraction x plus 1 quantity squared over 4 is 1. Thanks, sir. So now we have to figure out which one is it. Is it a circle, an ellipse, a hyperbola, or a parabola? Well, we know it's not a parabola because it's an x squared and a y squared. Which one of those 3 left over has a subtraction? Hyperbola. So this tells me I have a hyperbola. And if you want, what I would do is this right away. Put it over 1. Doesn't change anything, does it? Now, if my hyperbola, I have a y squared hyperbola, so it's y minus k quantity squared over a squared, x minus h quantity squared over b squared is 1. Your center is still at the ordered pair, H, K. Where's your center located for this parabola? Excuse me, hyperbola. -1, -2. This is the one that people will mess up because what came first here? The K value came first. So in this example, it's HK. It's backwards the way it's written. More often than not, this is where students make the mistake, is that they accidentally flip-flop the H and the K. And that'll also happen with parabolas because the y squared comes first. Okay? What's wrong? Hyperbola? Because hyperbola is the only one that has a subtraction symbol in it. Yeah. I'm not just saying it for the sake of saying it. Is that hyperbole? It sounded good. I never exaggerate. Right? So, in this case, hey guys, in this case here, again, you'll notice what most people will screw up is they'll flip-flop their H and K. And if you do that, you'll just put yourself in the wrong quadrant, and you'll probably get everything else right, but you'll be placed wrong right off the bat. Happens all the time. Pay very close attention if you have a y squared first. So we still have an a squared value, which is 1, a b squared value, which is 4, which gives me a c squared value of what? Well, hyperbola. Is it a squared plus b squared, or is it a squared minus b squared? It's plus. What's the way to remember that? Yeah, it's opposite of what the, just remember. It's the opposite of what the equation is. Or, just remember. Okay. Now, I wanted to take time here to make sure that we all see exactly how we label and work with the hyperbola. Now, the hyperbola that you did yesterday, the only difference was your center was located at the origin. Today it won't be, which means that you won't necessarily know where your y-intercept is. So we're going to have to use one of our ordered pairs that we get to be able to write the equation in line of the asymptotes. Okay? That's the part that takes longer with these. So let me put a double screen here and show you what's going on. Now we have a hyperbola. We know that the center is going to be located at -1, -2. So left and down. So -1, -2. There's my center. Right. What direction is this going to go? Up and down or left and right? It's going to go up and down because what came first? 5. So I'm going to make sure I do this. I now know that my A value is 1. So I have to go up 1. I have to go down 1 from the center. So if my center was at -1 and -2, I go up 1. I go down 1. So now my vertices are located at -1, -1, -1, -3. What I'm doing here, guys, is a little trick that I want you to try to get used to doing with shifted bins. As soon as you plot something, write down their ordered pairs. That way it's a little bit easier than having to go back to try to remember doing things like that. It's a little bit easier. It's cleaner to know, all right, I just went up and down 1 off of that, and it's easier to remember. Okay? Do the same thing with your covertex. My covertex value is B. I'm going to go left and right, 2. Okay? So when I go left and right, I know your phone's probably really, really awesome. How about write something down? That's how you better. Wait a minute, because you missed all this yesterday. So I go left and right, 2 from the center. So 1, 2, 1, 2. And I write those down. The covertex then is at -3 and -2 and 1, -2. We all right with that? moving left and right. Hyperbola then gets a box around the edges. Which means I have to then put in my asymptotes. And since we're no longer centered at the origin, I can't say that I can just write down my slopes. I have to figure out the equation of the line of the asymptotes. But I still find my slopes the exact same way every time. Up and over, rise over run. Okay? You were talking about, is it B over A over B? Don't concern yourself with that because that's more stuff you have to worry about. It's much easier just to remember that, all right, I went up 1, I went over 2. What's my slope? 1 over 2. Then the opposite then happens. I went down 1 over 2. So my 2 slopes then are going to be, one of them is at positive half, the other one would be at negative half. Are we all right with that? Now, right away, I have an ordered pair that both of those slopes went through. They both happen to go through what? They went through the center, didn't they? So when I write out my equation for my asymptotes, I'm going to use point slope form. And I basically do that twice for the asymptotes. One with the positive slope and one with the negative slope. We get y plus 2, 1 half, x minus 1, 1 half, x minus a half plus 2 is 3 halves, I believe. Oh, I'm sorry, negative 3 halves. Sorry, I've screwed that up here. Negative 1 half, subtract 2 should be negative 5 halves. I'm sorry. I was thinking of the negatives there. And then the positive slope would be at did I write minus 1? Oh crap, it's supposed to be plus 1. That's why I was doing it in my head. I'm sorry. I screwed these exact same slope up in the first hour too when I learned my lessons. So what's negative 2 plus a half? Negative 3 halves. I knew I was getting there. And then the other one, this would be a plus 1, so it'd be a negative half. The other one would be the negative 5 halves. Those are my 2 equations then. I had it, but I got it wrong. Sir? I'd rather you write it out in slope-intercept because that's your standard way of doing it. Plus, math team questions ask you that, so I'm just trying to train some people that might have to take that test. It's a self-fulfilling prophecy right now. So Devin, learn that. You didn't yell yes? Oh, the bond got turned down. Never mind. All right. So last thing we have to do then is plot our focus. Our focus, we know it's got to go up and down because it's an up and down from the center. Now, here's what's weird about when you plot your focus. Your focus is the one that usually has the square root thrown into it. Yes, ma'am. Where are you at? Yeah, sorry, it's a 5. If you squint just right, it looks right. Becky, you got 7 minutes. Okay. And then when you have the square root of 5 is a smidge more than 2. You okay with that? So what we do is we start at our center. Here's up 1, up 2. Here's a smidge more. Down 1, down 2. Here's a smidge more. So our foci are located there. The way that we write the ordered pairs, it's really easy. All we have to do is this for the foci. I'll slide this up here. The foci. Did I change my x value to the foci in this case? No. I just added and subtracted to the y value because I moved it up and down. So it's going to be at negative 1. Because that was our, oh, I'm sorry. It was negative 1, and then it's going to be comma negative 2 plus root 5. You just write it with the plus and a minus with the square root. No matter how ugly the square root is. Just like we did yesterday when it was at 0, 0, we said, 4 comma 2 root 3, 4 comma negative 2 root, or 0 comma 2 root 3, 0 negative 2 root 3. We wrote it with just the radicals in it. You can do the exact same thing. I don't want you guys to figure out decimals. Don't worry about it. You're just rough sketching where things go, and you go from there. Yes, ma'am. A's and B's. Yes, ma'am. Because your distance from your A value is always the distance from your center to your vertex. B is always the distance from your co-vertex. And then lastly, hug your asymptote, go through the vertex, hug your asymptote, hug the asymptote, go through the vertex. Oh, that was the focus. Yeah. And you know what happens a lot of time with that? You'll label everything out knowing that you were doing an up and down one, and you actually draw the curve the wrong direction. You'd be surprised how, when you get into this, you start thinking, there's a boatload of parts that can go wrong. If you do just one silly thing, but yet you do all the math right, it's a very labor-intensive grade, shall we say. And that's kind of what you wind up with a hyperbola. That's the worst-case scenario style one. That's one that just takes the longest to do. All right? But really, if you think about it, you're just reusing all the information we talked about the past few days about what does A stand for, what does B stand for, what does C stand for. You know what the correct direction things are going. I'm not going to take the calculator or the formula away from you so you guys won't be able to figure out where things are going. You just have to understand what things mean. That's where the A, what does the A stand for, what does the B stand for, what does the C stand for. All right. Let's look at an ellipse. No. Because you have to figure that out. And we'll talk about how you do that. It's not easy. So get your ellipse glasses on. That's good. That wasn't good. No, it was cloudy out, remember? No, it was during the school year. Oh, that's right. No, that's right. It was like the Friday before school started, wasn't it? That's right, because we had an institute day, and it was really cloudy out. It was kind of So let's look at an ellipse. The ellipse, remember the difference between the ellipse and the circle is that the ellipse will have different values for your a squared, b squared, whereas the circle, your a squared, b squared will always be the same. Now, what was the rule about a squared and b squared with your ellipse? Do you remember? A squared is always the bigger. Good. So we know then that our generic formula, if we look it up, would be x minus h quantity squared b squared here plus y minus k I squared over a squared is 1. Our center is still located at h and k. Well, in this case, where's our center? 3, -6. Very good. Is this being pulled left and right or up and down? It's got to be pulled up and down because it's underneath the y. Remember, again, you don't have to memorize it because it's on the thingy for you. The picture will be there. Okay. You know it's got to be pulled out like that. And now, what's your a squared? 49. Our b squared, 25. Our c squared then will be what? About 3 minutes. 24, very good. So our A then, plus or minus 7, B, and you'll see right away that a lot of these values are going to have 4s, 9s, 36s, 49s. They tend to make sure that everything works out to be pseudo-clean for you as far as your A squareds, B squareds. Even the one that you had yesterday where it was like 81 over 16 or 81 over 25, I think it was like 9/5. I think we've seen that one. It's not awful. I mean, it sucks, but it's not like terrible. And then it is quite literally just start plotting away. Right? Ellipses are easy because you don't have to worry about all the asymptotes. So we got 3, -6. There's our center. From there, our A values have to go up and down 7. So and then so I write them out. I add and subtract 7 to the -6 to get the 1 and the -13. Go vertex. I'm going to go left and right 5. Oops, that's 3, 4, 5. Then that -2, 1, 2, 3, 4, 5, and 8. And again, notice the A value I'm adding, subtracting to the X value here because I'm moving it left and right. The Y value stays constant. Oh, thank you. I thank you. Yeah, so it was 8. I don't know why I wrote it there. Draw the oval. That's the really hard part. God, it's awful. It's not even close to it. I gotta go talking. Julio. And then lastly, we have to walk our focus. Our focus value is the square root of 24. Square root of 24 is a smidge less than 5. So we just got to move up and down 5 to plot our dots. 1, 2, 3, 4, 5-ish. 1, 2, 3, 4, 5-ish. And then we just write it down. Now, it's going to be easier to see it here when I write out the foci. The foci went vertical. It didn't change along the x value. So we know that the x coordinate for the foci is going to be the same. It's still going to be at 3 for both of them. For one of them, you just throw my finger back there. For one of them, I added 2√6 to the center. The other one, I subtracted 2√6 from the center. So my ordered pairs would be at -6 plus 2√6 and -6 minus 2√6. That's all you have to write it as. You don't have to do anything fancier with it. There's no reason to. Okay? That's the way that those guys would look. All right? Good times had by all, right? All right. What haven't we done yet? Prep. Waiting, looking for my water because I'm thirsty.
Right here.
Oh, thanks. You were trying to steal. All right. We cool? No. Oh. Sorry. I was sorry. I was going to stare at that. All right, let's look at a problem. All right, last one. Last one is going to be our parabola. And the reason we always know that we have a parabola is because one of them's not squared. Very good. You're only going to have one value squared for a parabola. It's either going to be an x squared or a y squared. So right now we know we have an x squared parabola. Which means what direction is this? Or even more so, we know what direction this is going to go. Where? It's going to go up. It's an x squared parabola, and notice that this value is positive, so it's got to move up. So the equation looks like this: x minus h y squared equals 4p y minus k. It looks eerily similar to that 4px or 4py equals either an x squared or a y squared. All they're doing is just throwing the h in. So in this example, where's our center located? Very good. Our center is located at -7 and 3. What's our p-value going to equal here? 3. Very good. So remember, your p-value is going to be 3 because you set the 4p equal to 12. And that's what tells you that it's moving upward. Okay. What's that distance of p stand for again? I know it's been about a week since we did that. Remember what that stood for? From what? Say it. I think you had it. Say it. You're right. The p-value is always the distance from your vertex, or in this case, our center, to our focus. Okay. So when we plot this, there's my center. I know it's got to open up. Remember, your vertex is always going to try to open towards the focus. So it goes up 3. So our focus here, well, it's at -7 and now 6. It's going to do that. What's the balancing thing called again for a parabola? The directrix. The directrix is located, if this is up 3, the directrix would be at down 3, and the equation of the line of the directrix would be a horizontal line. And what's the equation of every horizontal starts like? What equals a number? Y equals a number. In this case, our directrix would be at y equals 0. Okay. The directrix, remember the directrix is the balancing point that's behind the parabola. That's equidistant. That distance from the directrix to the parabola is equidistant from the parabola to the focus. And basically what happens is, the point here, if you bring it out to here and here, those two distances, and the distance from here to here, if I'm not mistaken, this stays the same between them as it goes around. Something like that. Okay. Sir. P-value. Your p-value is positive to go up or right, depending upon if it's an x squared or y squared. If the p-value is negative, it's down or left. That's how that works. Right. I have 4 of these for you guys to do today. Okay? 1 of each style. Guess which 2 are the easiest? Actually, parabola. I think parabola is easy. Ellipses is a close second. The hyperbola just takes a little while. I just want you guys to practice on labeling everything. Okay? I forgot what page it was, but it's 628, it's 10.6, 21, 23, 25, and 28. What's that? It's 1 of each type, yes. Better we got. 2, 3, 4, and 5. Okay. Those will be the ones for tomorrow. Those 4 questions, hey guys, But Bradley was asking earlier, it's like, how do you know what they are if you don't have them in that format? Well, we're going to start with that problem tomorrow about how do we get them into that format. And it goes back to the old-fashioned, good old completing the square. And you're gonna get so good at completing the square, it's gonna be crazy. Yes, ma'am. Is that all right? Yeah. There we are. We'll do all that completing the square one tomorrow. Friday we'll probably get into the equation stuff. Yeah, go right ahead. That's what they're there for.